Assalamualaikum and hi. Today I will present about the project named A Sustainable Solution in Refrigeration and Air Conditioning. Let me introduce our group members. First is me, Aisyah Izzati. Second is Nur Fatina Diha. And third is Nur Hanisa. Now I will talk about the introduction. So what is the importance of refrigeration? Refrigeration is essential for preserving food, creating comfortable living environments, and supportive productivity. It slows down bacterial growth in food and provides cooling for homes, workplaces, and industries. However, traditional refrigeration has caused environmental problems like ozone depletion and global warming. So, what is the environmental issues with refrigerants? Refrigerants like CFC and HCFC harms the ozone layer, which protect us from harmful UV rays. A single chlorine atom from CFC can destroy thousands of ozone molecules. These substances also contribute to global warming by trapping heat. This led to efforts like the Montreal Protocol to replace harmful refrigerants. So, what if HFO as a solution? Hydrofluoroolefin (HFO) are environmental friendly. They have low global warming potential and do not harm the ozone layer because they do not contain chlorine. HFO like HFO-123YF are energy efficient, safe to use, and work well in modern systems with minimal changes. They are versatile and used in various applications such as car air conditioning and heat pumps, making them a sustainable alternative for the future. So, let's move to the problem statement. What is the environmental impact? Refrigeration and air conditioning systems use harmful refrigerants that contribute to global warming. Regulation rules like the Kigali Amendment and EU laws require switching to environmentally friendly refrigerant. What is the new alternative? The alternative is to use HFO like HFO-1234YF are better for the environment with low global warming potential and no ozone damage. So what is the challenge faced? The new refrigerants need to be ensured it works well with the current system. The refrigerants also must be improved or keep the same system efficiency, and the cost of switching can be high. So the project goal is to create a sustainable solution using HFO refrigerant, and also it focuses on reducing harm to the environment while keeping system effective and efficient.
Hi, Assalamualaikum. My name is Nur Hanisa binti Zulkifli. For the next part, I will explain about comparison process between conventional and green technology refrigerant. In this part, it divided into two parts. The first part, I will explain about comparison composition between conventional and green technology refrigerant. And the second part, I will explain about reaction synthesis of conventional and green technology refrigerant. Refrigeration technology that rely on the refrigerants that significantly impact the environment. Traditional refrigerants such as chlorofluorocarbon, CFC, and hydrofluorocarbon, HCFC, are halocarbon-based compounds containing chlorine, fluorine, and carbon. These refrigerants have high ozone depletion potential (ODP) because chlorine atom in the stratosphere break down the ozone molecule, leading to ozone layer thin. Furthermore, their long atmospheric lifetime result in high global warming potential (GWP) contribute to significant to climate change. To address the environmental issue, the widespread demand for chlorine-free refrigerant led to introduction of hydrofluorocarbon (HFC). HFC were initially projected as environmental friendly alternative to CFC and HFC because they have zero ozone depletion potential value and do not contribute to ozone depletion. However, their global warming potential and long atmospheric lifetime have raised significant environmental concern, diminishing their appeal as sustainable refrigerant. The focus now has shifted to the hydrofluoroolefins (HFO), a newer class of refrigerant composed of unsaturated molecules with hydrogen, fluorine, and carbon. HFO are characterized by the presence of carbon-carbon double bond, such as in HFO-1234YF. This structure allows for rapid atmospheric degradation, significantly lower their global warming potential and making them more environmental friendly. HFO also improve energy efficiency. For instance, HFO 1234YF often compared to HFC 134A demonstrate a higher coefficient of performance which reduce to electricity consumption. Studies show that HFO 1234YF has 15.5% higher COP than HFC 134A when assessed using the energy method, focusing on energy input versus cooling or heating output, meaning that it requires 15.5% less energy to produce the same cooling and heating effect. And then it has 90.8% higher COP when evaluated using the entropy method, which accounts for thermodynamic efficiency and entropy change. Next, I will explain about the reaction and synthesis of conventional and green technology refrigerant. The synthesis of fluorofluorocarbon (CFC) involves a two-step process, which is halogenation of methane and subsequent fluorination. The first one is halogenation, which is chlorination of methane. Methane CH4 will react with chlorine Cl2 under ultraviolet, which is UV light, in a free radical substitution process to produce chlorinated methane compound. The reaction between methane and chlorine can continue under ultraviolet light to lead to formation of chlorinated methane compounds such as chloromethane, dichloromethane, and trichlorfluoromethane, and further products as the hydrogen atom in methane are replaced by chlorine atom. The reactant is methane and chlorine, and the product is chloromethane and hydroxide hydrochloride. In the next step, trichloromethane CHCl3 undergoes a fluorination reaction. Hydrogen fluoride or fluorine gas introduced to replace one chlorine atom with fluorine atom, producing trichlorfluoromethane CCl3F, a common CFC. The reactant is trichloromethane CHCl3 and hydrogen fluoride HF will produce trichlorofluoromethane CCl3F and hydrochloric acid HCl. Next, synthesis of hydrofluoroolefin HFO. Green refrigerants, specifically hydrofluoroolefin HFO, are synthesized from fluorinated alkenes through processes such as hydrofluorination or dihydrohalogenation. These methods rely heavily on catalysts to produce environmentally friendly refrigerant like HFO 1234YF, which characterized as unsaturated carbon-carbon double bond. A key reaction in the synthesis of HFO 1234YF involves the conversion of chlorodifluoromethane (CCl2F2). The process replaces chlorine atom with fluorine atom and introduces a carbon-carbon double bond, forming an isolated structure. The reactant is chlorodifluoromethane (CCl2F2) and hydrogen fluoride (HF) will produce HFO 1234YF, which is CF3CH double bond CH2 and hydrochloric acid HCl. For the last part is catalysts. Catalysts play a significant role in the synthesis of hydrofluoroolefins HFO by activating reactants through the weakening of existing chemical bonds, thereby promoting the reaction. They enhance selectivity to ensure precise fluorination and the correct introduction of the carbon-carbon double bond, while reducing energy requirement for lowering activation energy, minimize the need for high temperature and pressure. Common catalysts such as chromium-based catalysts, aluminum fluoride, and activated carbon support catalysts ensure higher reaction rates, improve yield, and reduce byproduct formation, making the process more efficient and environmentally sustainable. HFO offers several environmental advantages, including the elimination of chlorine from their structure, which prevents ozone depletion. Additionally, the unsaturated carbon double bond in HFO facilitate rapid atmospheric degradation, significantly reducing their global warming potential. Overall, the synthesis of HFO emphasizes environmentally friendly and providing long-term sustainability and refrigeration application.
Next, I will continue with our discussion. Why HFO are better for the environment? In the past, chemical called CFC and HCFC were used in refrigerator and air conditioner. A common name for CFC is R12 and HCFC is R22. While they work well, they also damage the ozone layer, which protect us from harmful UV rays. They also contribute to climate change. For example, R12 traps 10,000 times more heat than carbon dioxide. That's why international agreements like the Montreal Protocol decide to reduce their use. HFO like R1234YF and R1234ZE are much better for the environment. They don't destroy the ozone layer and trap far less heat. Plus, they break down quickly in the atmosphere and causing less long-term harm. Next, why HFO are a great choice? HFO works well with existing cooling systems, so companies don't need to completely replace their equipment to start using them. Their energy efficiency, which means they help to save electricity and reduce pollution. HFO are also safer for workers because they are less toxic and only slightly flammable if handled carefully. Plus, using HFO fits with the green chemistry principle, meaning they reduce harmful chemicals and waste during their production and use. The last one is challenges and future of HFO. Even though HFO are better, they also have some challenges. They cost more than traditional refrigerant, which can make it hard for smaller businesses to afford them. They also don't work as well in very high temperature, but scientists and companies are working hard to solve their problem. They are improving the technology and also lowering costs. In the future, HFO are expected to become cheaper and easier to use everywhere. In conclusion, understanding organic chemistry is important in developing green technologies because it can help in designing and creating environmentally friendly solutions. Organic chemistry describes the structure, properties, and reaction of compounds, which allows scientists to develop alternatives such as replacing CFC and HCFC into HFO. By applying organic chemistry, we can create environmentally safer materials such as refrigerant with low global warming potential and no ozone depletion effects. It also helps reduce waste and increase energy efficiency and aligning with the principle of green chemistry. Overall, organic chemistry gives us the knowledge to innovate and build sustainable technology that protect the planet and improve our quality of life by protecting human health. That's all from us. Thank you.